This is the ET335 data latch lab demonstration, and it's going to be the short version, assuming that you have a handle on multisim, and I'll do a longer one that I do everything. Okay, in this shortened version, I'm going to show you where to grab the components, and you could put them together later. The longer version, I'll go ahead and build the whole circuit, but let's go ahead and just get the components, and I will allow you to I will give you this file. So that we need a VCC, we need a ground, we're going to need resistors, and actually we're going to need SPT switch since he's here. And let's grab a resistor. I believe we're going to need a 470, and I think we need a 1K. Okay, so let's go to TTL, close these out, and let's go to TTL, and we want to go 74LS, and we're going to use the 7400 for our SR latch, our debounce, and we're going to need a 7475. And there's two in an IC, and let's grab a 74175. Okay, and let's see what else we're going to need. Let's grab some LEDs. So we're going to go to diode, LED, and I think we're going to need a green and maybe a red, and how about an orange? Okay, if these things don't behave themselves and don't light, go ahead and open them up, and maybe we need to reduce the current. Most of them should work, but if we're having trouble, go ahead and just reduce the current on that. So we got the resistors, we got that, we got the switch. Oh, we need a clock. So we're going to go to power, sources, signal sources, clock. Okay, I think that's pretty much it. Okay, we're back at multisim. So let's move some of these components away, and let's build a debounce switch. So we're going to have two 7400s, so I'm going to copy and paste another one of those. Get rid of our clock and our 1K. I want to rotate that guy 90 degrees, and I'm going to make another one. And we're going to use two 470s. Let's rotate that 90 degrees. Good. And we're going to use LED 1, so we don't need that. We're going to need our switch. Okay, so let's flip that guy horizontally, because we need two inputs and we're going to have one output. Excuse me, let's go the other direction. Sorry. Let's go the other way. Let's flip him back. There we go. We need two outputs. Sorry. And this one's just going to be a ground. And our switch is going to go up to the input there, and the other one's going to go to the bottom. And let's move that up. Let's move everything up. Put our LED in there, and we're going to come off right there. And actually, we just need one LED. Excuse me, one resistor. Let's get rid of that guy. Move him down. going to come off a Q on the top, so let's go here. And this one's going to go up to the first input. And that's going to go to the output like that. And let's go ahead. That's our LED's fine. So let's get a ground. Copy and paste that. And let's hook up our, in this case, they're going to be pull-up resistors, because this is a normally low device, so that's why we have a ground here. So we're going to use our VCCs on both ends. And let's flip him vertically. We can move that down out of the way. And let's see, 470 LED. So here's our debounce switch. Good. Here in Multisim, I have our debounce switch, and I've used NAND gates, which I think is in the lab, tells us to do that. And what I've done is set it up with a SBDT switch, except I've kept it in the normal configuration, so I have a ground. And this is a pull-up, this is a pull-up, this is an active low debounce, so I got a ground here, and we can produce our debounce signal here. Okay, so there's a set, there's a reset, and I would hang on to this circuit because we're going to use it quite a bit in the next few labs. Okay, so we have our debounce. Let's go ahead and finish our circuit. So let's go ahead and move this up in the corner. Get them out of the way. So there's our debounce switch. Now we're going to use our 7475. And we're going to need our clock. And we're going to need LED 3. Let's move this over. And LED 2. And we're going to need a couple 470s. So let's grab the 470s. I'm going to copy and paste those. And I'm going to need a VCC over here. And I need a couple more grounds. Good. So now we have our clock. And we're going to go into, we're going to flash our LED, and we're going to, this clock is going to be our input signal, and it's going into 1D1. And this is going to flash along with our clock. And let's go ahead and change our clock to 1 Hertz. And 5 volts, 50%, that's good. So let's take an output, and we're going to take an output from Q naught. There we go. Let's go ahead and flip him vertically and flip our power supply vertically. And what we're doing is we're using the Q naught, so every time Q goes low, our LED should flash. Okay, our clock is going to go into data, and our enable is actually going to go into our debounce. So let's take a look at that. So that looks good. Here I have the completed multi-sim diagram of our data latch. This is the 7475 data latch, which is a gated one. So whenever it's enabled, it will pass the data on through. This is called a transparent latch, and I'll show you what that means here in a second. But first thing let's do is we have our debounce switch. That is going to be our enable. So when this LED is lit, it's going to be a high, so our gate will be enabled. This clock here is actually our data. Okay, so we have 1 hertz going in. That's going to be our data. It's going in the output to the data. And every time we put in a little bit of data, we're going to get our LED to flash. Here I have our LED hooked into Q0. Okay, so this one is set up for syncing, and it should be in sync with this other clock here. So let's go ahead and start. Alrighty, so we have high here, so we're enabled, and we see the data passes straight through. These two LEDs are in sync. Okay, so we have data in and we're getting data out. This is the transparent mode. Everything comes in, goes out. Okay, so let's trap a high. Alright, so I trapped a high. So when this guy went high, I went ahead and moved this debounce switch from high to low. So I captured that. So this is latched high. So let's go ahead and get it flashing again. And now I'm going to trap a low. And I've done that. So I could go ahead and control this to trap data on both sides. So I just trapped a low. And that's pretty much it. Okay, I've saved this so we don't write over our last design, and I'm going to use 74175. So I'm going to get rid of our transparent D-latch, and I'm going to move up our new latch, which is a edge trigger device. So I'm going to use the clock, which is going to be coming off our debounce. And this clock here is going to be our data. So we're going to use our first gate that's in this box of 4. And I'm going to, let's add another VCC because we need to undo our clear, make sure it doesn't bite us. So let's do that and flip them vertically. Let's go to clear. And our output. So we're going to come again. This is pointing towards it. So again, we want to go to Q0. And that's all we need to do. It's pretty easy when we have most of the components already there. Okay, here we have our 74175 data latch. It is a positive edge triggered device. Okay, here we have the clock, and we're going to use our debounce as our input. Okay, and we have set this up where we have our clock in, which is our data. Our data is going to flash this LED. This LED is going to go to our D latch, excuse me, our SR latch, and here's our output. And again, I hooked it to Q0, so that's going to be in the syncing mode. This device is not transparent, so we are not going to see the inputs and the outputs synchronized. Okay, so I'm going to have to trap whatever I want to see. So let's go ahead and start. And since this is a positive edge trigger, okay, we need to go from low to high. So let's start at low. Right now, let's grab a high. All right, so I went from low to high, which is what? A positive edge. So I latched a high. All right, so let's go create another positive edge, and let's grab a 0. And I grabbed a low. Okay, so the only time that this data is going to get trapped is when I go low to high on the clock. And that's pretty much it.